Have you ever imagined what it would be like if blindness could be reversed? Not with glasses, not with surgery, but with a chip inside the brain. Sounds like a sci-fi movie, right? Well, what if I told you this is actually happening, and the man behind it is Elon Musk? In today's video, we'll dive into how Neuralink's brain chip implant technology is attempting to make the blind see and whether this is truly a miracle or an incredibly risky experiment. Buckle up as we explore the science, the potential, and the dangers of this revolutionary technology. What is Neuralink? Neuralink is Elon Musk's brain-computer interface company. In simple terms, it's trying to connect the human brain directly to computers. Their bold goal? Restore vision to the blind, cure neurological disorders, and eventually, enhance human capabilities. And this isn't a distant dream. Neuralink already has FDA approval to begin human trials. But before we celebrate, we need to ask, what exactly are they putting inside the brain? Neuralink's ultimate vision is much bigger than just medical interventions. Musk believes the company's work will lead to breakthroughs that can help people with neurological disorders like Parkinson's disease, Alzheimer's, or even depression. Their long-term vision includes enhancing cognitive functions. Imagine people being able to access information directly from the internet, or even upload their memories. But we need to understand more about the technology they are developing before we can get there. How does Neuralink work? Here's the quick version. Normally, your eyes act like a camera. They capture light, the retina turns it into signals, and the optic nerve delivers them to your brain, where your visual cortex creates sight. If that system breaks down, blindness occurs. Neuralink wants to bypass those broken parts completely. Instead of light hitting your retina, a camera would capture the image, a chip would process it, and electrodes implanted in your brain would simulate vision directly. Basically, replace your eyes with a computer. Amazing idea. But here's the catch. Neuralink's technology aims to be even more sophisticated than simply restoring sight. Their system could potentially allow the brain to process a much broader spectrum of visual data, far beyond what the human eye can naturally perceive. This could open up possibilities for things like supervision, where the brain could interpret things like infrared or ultraviolet light. It's a whole new frontier for what humans could experience. But, as mind-blowing as this sounds, it's important to remember that this technology is still in its infancy. Neuralink has achieved some remarkable feats in animal testing, but making the leap to human trials is a massive next step. What makes Neuralink different from other BCIs? BCI technology has been around for a while, but what makes Neuralink stand out? One of the key differences is that Neuralink's device uses ultra-thin, flexible electrodes, unlike the older, rigid arrays used by other companies like Second Sight. The flexibility of these electrodes means they can be implanted with greater precision and are less likely to cause damage to the brain. Neuralink's use of flexible electrodes has the potential to minimize the formation of scar tissue, which can interfere with the signals the device transmits. This makes their technology more viable for long-term use compared to older, more rigid implants. But it's not just about how the electrodes are implanted. Neuralink's system is also wireless, allowing for more freedom of movement. The data from the camera is sent wirelessly to a smartphone, which then transmits the visual information to the implant in your brain. This system will allow users to experience sight without the need for bulky equipment or cumbersome wires. The surgery. To make it work, you need brain surgery. First, a hole is drilled into the skull. Then ultra-thin electrodes, thinner than a human hair, are inserted into the visual cortex. These connect to Neuralink's chip, which sits inside your skull. The surgery is so delicate that it requires a custom robot, the R1, that can place electrodes with hair-splitting precision while avoiding critical blood vessels. Sounds futuristic, right? But with surgery this invasive, you probably know what's coming next. The R1 robot is crucial because human hands simply cannot match the level of precision needed for this kind of procedure. One tiny mistake could make the difference between a successful implant and catastrophic damage to the brain. These robots have the ability to adjust in real time, ensuring that the electrodes go exactly where they're needed in the brain. This precision is vital, not just for the success of the implant, but for ensuring that the brain doesn't suffer any long-term damage from the procedure. The idea is that the electrodes will remain functional for a lifetime, without causing irritation or inflammation to the surrounding brain tissue. But, as with any cutting-edge technology, we need to ask, will it really stand the test of time? The risks. Any brain surgery carries risks: infection, bleeding, or even permanent damage to brain tissue. And there are bigger unknowns. What happens when technology evolves? Will patients be stuck with outdated implants? What if Neuralink stops making updates? People could literally lose their sight again because the company went out of business. And let's not forget, we're still learning how the brain adapts long-term to foreign implants. So, should we be racing ahead with this? Or slowing down? Neuralink's technology is powerful, but the question of whether our brains can truly accept these implants for the long haul is still unanswered. Over time, the brain naturally forms scar tissue around foreign objects, which could interfere with the implant's functionality. Imagine if this technology becomes obsolete in just a few years. What happens to those who have undergone the procedure and are left with nothing but an outdated device? Moreover, what happens when the implant malfunctions or gets disconnected? Neuralink needs to address how patients will be supported with these devices over the long term, especially if the company itself faces setbacks or ceases operations altogether. The bigger picture. Despite the risks, Neuralink could redefine what's possible. Restoring vision is only the start. Future applications could enhance memory, improve learning, or even connect human brains to the internet. Elon Musk dreams of a world where this isn't just for a select few, but available to everyone. A future where blindness, paralysis, and even human limitations could be hacked. But ask yourself, do we really understand the consequences of wiring human brains to machines? Elon Musk's vision for Neuralink stretches far beyond treating blindness. Imagine a future where the brain can connect directly to the digital world, allowing us to process information at the speed of thought. If we truly embrace this future, the possibilities are limitless. From enhancing cognitive abilities to communicating without speaking, it could change the very fabric of how we interact with the world and each other. But with this kind of power comes a deep responsibility. Neuralink's success could open the door to new ethical questions about brain augmentation, privacy, and the very essence of what it means to be human. We need to tread carefully as we embark on this new era of human evolution. So here's the question. Is Neuralink a miracle for the blind, or a dangerous experiment that could spiral out of control? Only time will tell. What do you think? Drop your thoughts in the comments. I'll be reading them. Thanks for watching. If you found this video interesting, don't forget to like, share, and subscribe to our channel for more content on cutting-edge technology, science, and innovation. Stay tuned for more updates, and I'll see you in the next video.